Thank you. My name is Damian Valles, and I would like to introduce my presentation on AI, specifically looking at fire responses and some of the education expectations that I think as a professor, seeing how the skills are interpreted to the classroom as well here at Texas State. So what I'm showing here is an actual residential fire. I'm looking at how firefighters are reacting to this live. I like to see what's going on in their protocols, and I like to see what's the reaction. I like to see the environment, the hazardous parts of the house. I like to see what's the incidents that are going on. This is literally a video from one of my friends whose neighbor's house was actually burning. Uh, and in the enhancements of this that I'm looking at, how can firefighters benefit from AI, and how can robotics benefit in this situation, how we can have dynamic data collections to make this happen, and if we do, what is the search and rescue expense of doing this? No one in this video is going into the house, yet they have no idea what's going on inside. Shouldn't they have some way or some reason to actually have knowledge of what's inside the house? And that's basically what we do in my lab. And here's another example of other possible, I don't know if they're playing, but I can actually get this going. This is in Buffalo, New York. This is a business who blew up right in front of a firefighter's face. You can see the reaction. You can see the debris that landed on the firefighters. You can see the explosion going up to them. These were unprepared firefighters going into what they know, a known scenario. You see the bystanders just looking around. These are really dangerous, toxic, and what they call a common scenario. Even though they knew what to do, they were still harmed. It was still explosive, and they didn't know how to react. Another use of this is in Hong Kong. You can see a residential apartment building on fire, and it's not the bottom floors. You can see the structure damage. You can see what happens of the firefighters just simply letting it burn. There's really no other reaction to this. And mainly because there's nothing else they can do. They can't do anything when it's that high. And sadly, we have buildings like that in Austin. We have buildings like that in any major city. And even though our firefighters are well trained with protocols, they don't know what to do when these things happen. And they don't understand what's the situation in the sense of what can be done. In my lab, what we're trying to do is engineer how we can provide data to them and be able to get them in more safer and better situated when these kind of critical emergencies occur, right? What we're looking at is how to build robotics that helps us collect data dynamically, meaning there's no infrastructure for data collection, and then we build it dynamically for them. And then we use robotics and drones in order to make that happen, right? The big assumption here is that we have to design these things without getting in their way, right? Because the moment we do get in the way of firefighters, it's the problem that the adaptability issue becomes a problem. One of the projects is that we need to be able to do person detection. Now, we had to build our own data sets in order to make this happen. The other problem is I cannot send students to a burning building or have a student be in the middle of a burning building. So we had to do image processing in thermal cameras in order to make the inverse of the temperature in the image being represented into an actual fire. But infrared cameras helps us to see through smoke. And through smoke, then we can be more precise in our search and rescue, right? So we have students who worked on this and successfully defended thesis where we published some of our AI networking models that were efficient. Then we moved into screaming. What if somebody was inside that house screaming? Well, if you've never been inside of a fire, it's actually very noisy. When it's very noisy with glass falling, with the structure actually burning, wood makes a lot of noise, furniture makes noise, people yelling makes noise, there's the ambulance and sirens making noise. Your screams can be drowned down. What we did is that we were able to do another research projects dealing with the challenges and separability of what a human scream sounds like when it's noisy under a fire, right? And be able to equip a rover with a microphone that can actually dissect these things. At some point, we did develop a rover. This is our second version of the rover, which it's very Mars rover design-like, mainly because we got the inspiration from NASA, because we know that terrains or unpredictability or the randomness of a structure can present obstacles to a rover, right? It's equipped with LiDAR, a depth camera, an IR camera, a lot of jets and nanos. It has microphones. It has a lot of things going in there. It has the motor controllers. It has a lot of gear going in there, right? So obviously this is not suited for an actual fire. Going inside 2000 degrees of temperature will melt any electronics that we have. We haven't addressed that point yet, but the AI in this rover actually works. It helps to self-navigate through obstacles, recognizes people, recognizes someone screaming. It will make actions based on those reactions. Everything here is what we in the lab call, and everyone else knows it as, edge computer on the device or on edge computation and inference implementation, right? There's other aspects that we have to address this, but we have improved, and we're literally on our third prototype of this rover. It's taller, has better wheels, better control of the motors, and it can go up and down stairs now, right? We can do this faster than humans. So if you have a tall building for firefighters to go up to, we have rovers that can outpace a firefighter with all the weight they have to carry, right? And get to floors that are much more in need of data and understanding what's going to happen when we do the search and rescue, right? The other problem is that, well, we need drones. Drones can help you to do several things, inspect things from high altitudes. You can see the roof emergencies of the structure if we do that, but we have to build our own drones. We have to equip them with our own AI. We have to equip them with our own prototype needs that we have. And you can see our prototype. This is our first drone that we literally 1 month ago got our first flight out of the floor and be able to take off. And so it's been in the works a lot in how we can help firefighters deal with this, right? And I think this could be a service, but I think what the panel said before lunch concerns me about adaptability. And that's one of the things that we are addressing this year in our research lab. What we've done also with digital twinning is that we use augmented reality with HoloLenses, and then we can remotely move a rover with just our fingers. What we've done is basically, in case our rover gets stuck inside of a fire, we can see the camera feed from the rover, we can see the data coming from the rover, and then we press buttons within the HoloLens itself, and then you can see the rover moving around the lab, and then you can just immediately see what the rover sees, right? You get that video feedback and you see the emergencies that could be useful for firefighters, right? To make sense of what's going on in there. So this is another team of groups that use the HoloLens in order to make something happen. And all these things have been enabled mainly because we incorporated a lot of search of AI. Well, why is this useful to begin with? One, we're building skills to students who are expected to know this by the time they hit their job market. Half of these projects have been done by undergraduates, people without diplomas. That's basically what we're looking at. People who 2 years ago were in high school. And the reason we do this in the lab is because I see a lot of industry partners who have and need this requirement of skills. They don't have classes. They've never read a textbook on this. But I think the AI and ability, the information and digestion they have to make helps them to actually accomplish with the right guidance the type of AI that it's actually needed. They're not concerned about the policies. They're not concerned about taking away jobs because we're not. The whole point of this technology is to enhance firefighter safety and enhance the search and rescue and provide this ability for everybody to be safe. However, the adaptability of this will be a problem if we don't sell this correctly. So we have to have a different strategy, not just by policy people or professors like me, but we would have to have the support of people who can see it and then be able to understand it. I don't know if you knew this, but last week or two, the New York Police Department launched a robotic police monitoring in subways, I believe. And they had a picture of an actual officer next to the robot. I don't know if the officer was faking the smile, but I think he was, right? But there's somebody there replacing a human position, right? To monitor the subway as a police department unit with all robotic AI, computer vision capabilities. Now, was this adaptive by the force? Probably not. And there was probably a lot of work based on that. But the moment somebody sees the benefit or they actually witness something, it's when the adaptability starts. The goal of my lab is that we get firefighters to look at all this technology. We're not trying to sell it to them. We're trying to show them where the benefits are. Because trying to talk to them, it will make sense at some point once they can see what's proven technology actually works, right? And I think the evidence of actually having these things will help at least our students understand how really their work impacts the real world. I've had part of these projects funded by the NSF, by Dell Technologies, NVIDIA, and currently by the Translational Health Research Center. So I've had funding agencies helping me build this type of projects, building skills, technology, and other things that we want to do. But we're still yet to address many things like the right type of communication. Do we need to encrypt that data? Do we treat the data like body cams? If your house is on fire and everything's being recorded, do you want that open to the public? That's a question I need to have with policymakers. Will the insurance let you have that? Should the insurance people have that data of your house, right? And if it's you who needed to be rescued, do you want those images to be open, like body cams? It becomes a personal data issue. If we're going to introduce this on the edge, all these AI enabled in order to improve humanity, we need to ask our question, is this going to be okay if your face is on that data? Right? Because if you have no stakes in it, then it becomes an easy discussion until you're the target audience of that data. So some of the AI essential tools is to me question the students, when is this an essential thing to actually do? And the skills that we need into what we do at school. Can AI education fit into any domain? That's another question I ask students. And what should be our expectations? I think what's happened with ChatGPT and everything that AI has enabled students now, I was telling the table over lunch, my expectations have gone up based on the availability of tools now, not just in my career, but my expectations of my students in their research, right? I didn't have that pressure when I went to school. Sadly, things are not fair. And so I have to use those tools to help my own career in order for them to enhance their career. Therefore, AI is really breaking how I'm teaching class, how I'm researching in the lab, and how I have to pursue a career on my own. And so even though I'm having fun with toys, I have to question and introduce this to students who yet, were in high school not so long ago. The impact of our curriculum has changed. The way we engineer, the way I went to engineering school is going to be different. The way we do projects and the way we do ethics will have to change. The way we do resources and affordability, well, it's going to require more money. Everything that we do will require more support. And the research with ChatGPT and all the generative AI, well, the expectations is that your project needs to be really impactful. And so the creativity cannot be taught. That's the other issue with when you're teaching classes, is that either some students have that ability and some students don't. But just the introductions of the tools themselves can actually be useful. So I answer questions with questions in order to bring in any food of thought. Will AI be the best fit to fix our mental issues? Right? The other aspect I bring this up is because I work with emotion AI. I actually do detect your emotional cues based on how you behave. I see people in my classrooms, and I can tell you the student who's bored. I can tell you the student who's paying attention, who's happy, who's really upset. Why? Because I can I've been trained to understand and detect those things. I also work on AI projects that do the same, right? And the fact that can it actually help us in the long run will be part of, do we actually trust it? Will AI understand addictions without data? We understand an addict when we see one, well, at least if you have a trained eye. But can AI help you with that? And that's going to be another challenge for people who take care of people with addictions. Should we as engineers just engineer things because we can? Part of the ethics of my class is that we have to discuss the fact that because you can do an AI or machine learning, that doesn't mean you should. You have to question it beyond the data. You have to question it beyond the purpose or its intentions. Some people take it on the other side. Just because I do have data and I apply AI, then it's going to work. And it probably does, right? But the thing is, all they're doing is spotting the fly on the wall and shooting a bazooka at the wall. Well, you will kill the fly and you will accomplish your goal. But did you need the bazooka? That's the question I bring to the class, because they think that just by having data, I should do AI. And that's not how engineers should be thinking. Or should government be the ones be in charge of it? Well, in the case of the firefighting, I may have to rely on them, because I don't do policies, I don't do govern people, and especially I don't know what to do with personal data when it's not mine. I do engineer technology that captures it. The problem is I don't know where to go with it. What are the expectations? Should high expectations be given to the students? Right? So then should that pressure exist just because the demand of the world we live in be applied to them once they're in college? Or should we train them the way we've always been training people in college? The question becomes more blurry, right? Because now there's some different needs for different things. New creativity methods will spawn because of AI. That's true. Every time we have some AI or new technology introduced, there's new jobs that people are very creative in creating, mainly because they got displaced or maybe because they have different intentions for different things. And whatever we have available now, the students I have in the class will not have the same job opportunities 10 years from now, right? There'll be very different things available. And in 5 years, this summit will have different discussions, mainly because everything changes between now and 12 months, right? What classes can I offer to the freshmen then? Right? Are we expecting high schoolers to know how to code and do AI by the time they're 18? Well, if you're using ChatGPT, probably you can fake it, right? And some people believe that fake it until you actually make it. But are you actually learning? And are you actually questioning the tools and the techniques that you're learning? Right. So the ethics part of AI and the part of me showing what the capabilities are of us in the lab, in the classroom, as engineers, well, shouldn't we question everything about, even because we can, even because we technologically can, and I show you videos of our robots moving because they can, should we even implement them to begin with? Until I show this to firefighters, they'll tell me the truth, right? The reason I haven't is because there's still a lot of prototyping to do. A lot of things will not work in actual scenarios. My drones will fry. My rover will melt at the doorway. So I'm not ready to do that, but eventually I will. And when that eventuality happens, I have to be ready to answer their concerns, right? And that includes me teaching students who can absorb this new idea and make it a beneficial one, right? And that's my role, to make sure they understand that it's not just for the sake of doing something, right? And so our purpose in our lab is to be able to provide these type of skills to students, because I see, like in our panels, our keynotes, is that the skill set and the demand of anyone engineering anything is becoming more complex beyond what we teach in the classrooms. And so my question to myself is like, well, what can I teach them to make sure that when they come to a summit like this, they understand what we're saying, right? So with that, I want to leave you with that AI topic, and here's my information and email if you would like to discuss anything. But I'm happy and open to any discussions about my lab or anything that deals with AI or anything related to that. Yes, sir.
Great talk. Could you just elaborate a bit further what you meant by AI in the context of mental, what actually that meant?
Yes. So the reason I bring that up is because I just learned that universities offer an athletic or sporting mental health majors now, or something like that, right? And so there's a new wave of being able to treat people with mental issues, or maybe depression, or maybe fatigue in athletes, right? And so there's an effort to address mental health issues in a very specific way in a university, but obviously there's the personal one. And some of the things that people are projecting is that within 10 to 15 years, AI is going to help us understand the brain so much more that we can literally at some point treat mental illnesses or issues that we have.
Would you consider using sensors to sense wellness, to change the ambiance, or kind of be predictive in a person's mood and maybe mitigate something there? Could that be actually something that's plausible? It's done in vehicles.
It's done. Yes, it's done in a lot of places. I think it's a personal call. I wouldn't want it, mainly because I think if I'm going to go down crazy, I'd rather be crazy, as long as I don't know. But I think it does make sense of maybe doing that. But maybe in 15 years, we find a way to be less intrusive in order to help humans how to treat that based on new discoveries, based on AI mental health issues, either biochemistry wise, physiologically wise. I don't know where the science would be, but if AI is aware of those physiological and biochemical reactions, maybe there's a better optimized ways to be less intrusive with you being probed with something. That's my hope. Yes.
Could you repeat the questions, please, for those Zoom?
Oh, sorry about that. He was asking me how do I feel about being treated of mental health, and how would I feel if I had sensors in my head to readjust my mood based on AI conclusions. Yes.
So this past summer, as I have done for many years, mentored two interns for part of the company's program for helping them get some career experience on real job, problem solving, etc. Both of them are developers, coders in this case. And they both shared a common concern about what AI was going to do for their job, what job should they go for, am I going to be obsolete by the time I graduate from college because this stuff is going to displace me. Software and programming will be one of the things that is impacted probably most materially about getting work done more efficiently, quickly. No code, low code, starting already to become prevalent. vector for improving productivity for non-data science or computer science people. So anyway, just exchanging that as a concern, and what I would recommend perhaps is that there should probably be at least a fundamental must-have a class in this topic as you go through college. Now, I know we're just getting into this mode this year with reacting to this, but probably deserves a quick pivot to help them understand what it is, what it isn't, what it's going to potentially do to improve their jobs or change it.
Absolutely, and I agree with you with the soft development aspect of it, mainly because I've been able, even in myself, develop a machine learning and deep learning models within 15 seconds. If you know what to ask to ChatGPT, if you know exactly what to ask, you will get exactly the code you need, right? Assuming, right, you have to understand that there's a process of you debugging, testing, validating what the answer was given, right? But I've been able to do something within 15, 30 seconds that I used to ask a student to do for several weeks, right? And so what is my expectation then of the student, right? Well, then you should be able to develop 10 models within one day and then be able to test within the next 10 days, right? And so the productivity of that, pinpointing and targeting exactly the performance that we're looking for actually occurs much quicker.
Right. And with hygiene, so some of the topics covered today, security and best practices, not always an easy thing to graduate from college with best practices.
Correct.
To do, and code improvement can be not just productivity fast, it can be best breed design.
Absolutely, and that, and sorry about that, but the question was I forgot about that. I'm a bad professor, by the way. The question was, well, it wasn't a question, it was more of a recommendation, I would say, right? About how to teach students in college about the ethics AI implications of what we're doing, moving towards their careers and what we're doing with industry necessities and requirements. So I think for engineers and computer scientists, that would be a massive class to have. Any other questions? I feel like I'm giving out a quiz. Anyways, the habits don't die when you're up here. So thank you very much. I appreciate your time.